Hey guys, welcome back. In today's video, we're going to take the Proxmox lab that we've been building up until this point and start using it for what really matters, hands-on learning of enterprise networking concepts. Up until now, we've covered high-level virtualization topics, things like standing up new virtual machines, creating VLANs within Proxmox, and connecting our VMs so that they can talk to one another. But this is where we get to the good stuff. By running EVE-NG inside of Proxmox, we can virtualize things like network switches, firewalls, and routers, and build end-to-end client-to-server connectivity so that we can see how packets actually move through a network across these different devices. By the end of this video, we will have installed and configured EVE-NG along with 7 different devices, a mix of virtual PCs, switches, firewalls, and routers, and establish end-to-end connectivity. In follow-up videos, we will then use this lab environment to talk through the fundamentals of network troubleshooting, how to architect a network, how packets move through your service provider network, and why things may break in the real world. This lab will also be able to support dozens of different vendor technologies so that if you have customer issues that you are facing, you can easily replicate them in this same environment. So let's get started. First things first, what is EVE-NG and why install it inside of Proxmox instead of bare metal? EVE-NG is a network emulation platform designed specifically for network engineers. It lets us virtualize real network operating systems, switches, routers, firewalls, and connect them together exactly as they would be in a production network. This isn't packet tracer or a mock simulation. These are real control planes, real routing tables, and real packet forwarding. So why install it as a virtual machine? Well, a lot of people do install EVE-NG directly on bare metal as we have with Proxmox, and that absolutely works. But personally, I prefer running it as a virtual machine inside of my hypervisor. This allows me to shut EVE-NG down when I don't need it and free those resources for other workloads that I may be working on or testing. And if I break something, which happens pretty often, I can roll the entire lab back in a matter of seconds. At some point, I may invest in another server which becomes dedicated to EVE-NG, but up until that point, EVE-NG becomes just one component in my larger virtualized home lab and not the whole machine. Now, there are trade-offs here. Because we are adding another layer of virtualization, this impacts performance, especially because we need to enable things like hardware virtualization and pass through resources directly to our virtual machines. But this isn't a production environment. This is geared towards learning, testing, and troubleshooting, and it's a trade that I'm happy to make. Now with that understanding, let's talk through the baseline lab topology that we plan on building today. We want to establish end-to-end client-to-server connectivity. So we're going to be building a branch office network, a basic WAN network, and then a network where our application server lives. For our branch office network, we plan to start with a virtual PC connecting into a virtualized Cisco switch, which then connects into a pfSense firewall. This is definitely a simplified topology, but it helps lay the groundwork for later labs. The firewall then connects into our WAN network, which will just be 2 Cisco routers. So we will have branch firewall connecting into service provider router 1. That then routes over to service provider router 2 before handing off to the application side firewall. Within our application side or server side network, we will have our firewall, which has public IP space directly connected to it, and then hands off to our application server, which in our case is just another virtual PC connected directly to this firewall appliance. So to recap, we have a virtual PC connected into a Cisco switch, into a pfSense firewall, handed off to a Cisco router, which then connects to another Cisco router before handing off to a second pfSense firewall, and finally an application-side virtual PC. We will be using the IP schema that we see listed here. Feel free to configure this in your environment and follow along. The first step here is to download the EVE-NG installer, and then we also need the client pack for our operating system. I've already downloaded the installer here. I went with the free community edition from the direct download link, and then you will need to download the client pack as well. I'm configuring for Mac, so I'll scroll down to the Apple OS X, and I'm using a M3 MacBook Air, so I'll use the Apple Silicon new version. This process may differ a little bit for the Windows side, but you get the general idea. For Mac, I'm going to open the installer. If you're installing from Mac, you'll more than likely run into an error saying that this is not from a trusted developer. So you'll need to come into your privacy and security settings, and then scroll down to the security section, and you will see that this was blocked to protect your Mac. You want to click Open Anyway, confirm, enter your password or Touch ID, and then proceed with the installation of the client pack. The client pack will install things like iTerm, RealVNC, and Wireshark, which will allow us to use tools within EVE-NG so that we can console directly into the components, run PCAPs, and so on. I will drop links to all of these downloads in the pinned comment on this video. Once we have downloaded the EVE-NG installer as well as the EVE-NG client pack, we can come into Proxmox. I'm not going to go through how to upload an ISO image. We covered that in a previous video, which you can reference if you're running into issues. I'm going to go ahead and create my EVE-NG virtual machine and select the ISO that we downloaded. Going to give it quite a bit of storage. as well as access to the majority of my CPU and memory resources. So I'm configuring 2 sockets, 8 cores for a total of 16 cores here. You will also want to change the type here to host, and this enables the hardware virtualization, which will be required by pfSense. At least it was in my instance. And then for memory, let me give it 32 gigs. We just need a single interface, so bridge VMBR0, which connects to our home network based on our previous videos, and we will confirm. We can go ahead and start our virtual machine, and then open the console. From here, we want to install EVNG community, so we'll press enter. From here, we will set our system language. We will then go down to continue and press enter, and we will wait for this process to complete. Once this is done, we can select the reboot option. Once the process completes, the device will reboot one more time. There's quite a bit of post-install setup that happens, so you will wait for the second reboot. After the second reboot, you will eventually be presented with the login prompt. To log into the CLI, the default username is root, and the default password is Eve, lowercase EVE. The first time logging in, you'll be prompted to set up a new password for the root user. You type in your password, press enter, and then you will need to confirm it. You can change the host name as well as the DNS name. In my case, I'm setting this up to receive an IP via DHCP, and access to the internet is via a direct connection. After pressing enter, the node will reboot once more. And once it comes back up, we can log in with our new password. You will also take note of the IP address. So in my case, 172.16.16.29 has been assigned to my node here. And I should also be able to now SSH directly to this machine using the new password that I set up. So I'll go SSH root at IP address, in my case 172.16.16.29, yes, using the new password that I set up, and I can now access via SSH. To access via the web console, we will navigate to that IP address in our browser, and to log in here, the default username is admin, and the default password is Eve, lowercase EVE. Before we start building our lab environment, we want to first download the images that we plan to use. I found this repo on GitHub, which has a lot of useful links to different vendor operating systems. We're going to be using a Cisco Layer 2 and a Cisco Layer 3 device in our lab, so we're going to download those images from here. I'll post a link to this repo in the pinned comment below this video. We will scroll down. We're looking for the Cisco switches section to start here. And in this video for our switch, we're going to be using option number 8, i86 Linux L2 IP-based K9. So we'll click download here. This opens up a new tab and we can use standard download. And then for our router, we're going to be using option number 15, which is Linux Layer 3-P-15.0. So these images here are often referred to as Cisco IOL or iOS on Linux. These are lightweight Cisco operating systems that can be used within EVNG. These are generally reserved for Cisco internal use, but can be very helpful tools in building a hands-on virtual lab. For our pfSense image, we can reuse the same ISO installer that we had used in our previous video to install directly on Proxmox. If you're just now joining us, this link will also be available in the pinned comment. Once you've downloaded all of these images, you should have 3 separate files. You should have a netgate installer.iso. You should have the Linux L3 zip, as well as the Linux L2 zip. You can then unzip these 2 files to be presented with their respective folders. From here, we want to SCP all 3 of these images to the EVNG host. From my Mac terminal, I'm going to go into my downloads folder. First, I'm going to find the different file names that I plan to copy, just so that they're easier to copy and paste. So we have our netgate installer. And then we will need to get these file names out of their respective folders. Now that I have my file names, I want to copy all 3 of these to the EVNG host. We will start with pfSense, so I'll do SCP, my netgate installer name, root at 172.16.16.29, : I'll input my EVNG password, and we will see the image start to copy over. We'll then repeat this process for the next 2 files. Once we have copied all 3 files, we can come into our EVNG host, again SSH root at IP address, and then put in our password. And we should see all 3 of these files in our home directory. So we have our netgate installer, as well as the Layer 2 and Layer 3 Cisco images. We then need to move both of the IOL, the iOS on Linux images, into the respective IOL directory. So we will do MV for move. You can type the letter I and then tab, star key. This will capture both of them. And we want to move these into the opt unetlab add-ons IOL bin directory. If we run an ls-la here, we see that those two images are no longer listed, but we can change directory into opt unetlab add-ons IOL bin, and again run ls-la and see the two images have been moved here. Now we want to move the pfSense installer into the correct directory. This process is a little bit different. It's not an IOL image, which we can see here in the path. Instead, we're gonna run the pfSense ISO using QEMU, basically KVM virtualization. So first thing we wanna do, we can go ahead and go back to our root directory. So cd enter, and we'll see that our netgate installer is still here in the root directory. We need to make a new directory to put the pfSense image. So we'll do make directory /opt unetlab add-ons, and in this case it'll be QEMU, QEMU /, and we're going to name this pfSense dash, and then it needs to be our version number. If the version number is not present, it will not detect as the correct image and you won't be able to boot this. So you need to include pfSense -version number. So we'll make that directory, and then we want to do move, so mv, our file name, netgate installer -amd64.iso, and we're going to put it in our new directory. So opt unetlab add-ons QEMU pfSense, and then we want to change this file name from netgate-installer-amd64 to cd-rom.iso. We will then go into that directory, and we see our file is here, cd-rom iso, same size as it was before, we just changed the name. With KVM, we need the installer file, the .iso, and we also need a virtual disk. So from here, we can go ahead and create the virtual disk. So we can do that by running /opt /QEMU /bin /QEMU-img create -f, format is qcow2, and the name we want to use is virtioa.qcow2, and we can make the disk size 8 gigabytes. We'll press enter. And now if we do an ls-la, we should see the installer as well as the disk file. All right, the last thing we need to do before we can use these images, the pfSense is pretty much ready to go. Our IOL images, though, do require a license key. So we can go back to our opt unetlab add-ons IOL bin directory, which is where we have our images. And we're going to create a script here that can be used to generate the license key. This is not my script. This script is easily found through a Google search, so you will have to do a little bit of digging on your own here. But I will issue the command vim keygen.py, enter. I'm going to copy this text, paste this in my file, Control-C, :WQ, exclamation point, and then I'm going to run this script. So Python 2 keygen.py, and this is our license key. So I will copy these two lines. So the word license in bracket, eve-ng equals, and then our license key. I'll copy that output, and then I'm going to create another new file, which I will name IOURC. I will paste that output into this file. Again, Control-C, :WQ for write quit, exclamation point. And now I should have my license file here as well. And this is what the output of my license file should contain. So starting with this open bracket all the way down to the semicolon at the end. Anytime we make any changes to images or disks, installer files, and so on, we need to issue a fixed permissions command, which is /opt unetlab wrappers UNL_wrapper -a fixed permissions. This is a handy command. Like I said, you'll run this anytime you make changes, for the most part, in CLI. So keep this handy. And before you start doing anything in the GUI, make sure you run this. Okay, we are now ready to start creating and configuring our nodes in the Even GUI. So if you haven't already, navigate to the IP address of your Eve node in your browser, and you should see this login screen. Again, the username is admin. The default password is Eve, E-V-E. The first thing we're going to do here is create our lab environment. So we will click this paper icon for Add New Lab. I'm going to name this Enterprise Branch Lab 1, and I'll click Save. This now takes us into our lab environment where we can add nodes. So I'll click this plus icon for add an object. The type is node. And first we will add our Cisco images. So you'll see here Cisco IOL is in the blue color. This means we have images available, whereas all of these others are grayed out. We don't have these images uploaded into either a QEMU or an IOL directory. So I'll select Cisco IOL, and then I have my layer 2 and layer 3 images available to me. So first thing I'm going to do is add a layer 2 image. If we go back and we look at our diagram here, we need one switch, we need 2 pfSense firewalls, 2 routers, and then 2 virtual hosts. So I'm going to start with this switch by selecting our layer 2 image. We can name this switch 1, and we will change the icon to a generic switch. I'm going to leave the resources as the default selected options. So Ethernet port groups, there's 4 ports in each port group. We only need 1, so 4-port switch. We don't need to adjust the CPU or memory. We are not going to add any startup configuration. We're going to manually configure this here in a little bit, and I'll click Save. So we see this switch now has been added. We're going to add our 2 routers. So again, select a node. We'll go to Cisco IOL again. And in this case, we will select our layer 3 image. We will name this router. We can leave the default router icon. Again, we only need 4 ports, no startup configuration. But in this case, we want to add 2 nodes. So I'll click Save. I'm going to rename these. I can come in here if I want and say this is SP router 1. We will refer to this one as SP router 2. All right, now I'm going to add the pfSense firewalls. There are a couple of additional changes we need to make here. We'll search for vendor template type as pfSense. We want to add 2 nodes. We will use the image that we uploaded, the 2.8.0 image. We can leave the icon as the generic icon. We want to add 3 Ethernet ports. So the reason for this is that we need a northbound port for our WAN interfaces. We need a southbound port for our LAN interfaces connecting to our switch and our virtual host. And then we're also going to add a management network that will allow us to manage these firewalls from our home Wi-Fi. So I've selected 3 Ethernet ports. In my case, my server is very old and does not support some of the virtualization flags that are required by newer images. So that is why we enabled host virtualization earlier. That's required with this image. And we did that by setting the CPU type or processor type to host in Proxmox. And then we also need to change the QEMU version, architecture, and NIC types. So I'm going to go from TPL to 6.0. On my architecture, I'm going to go from TPL x86 to simply x86. And same thing from TPL VirtIO to just VirtIO-net-PCI. I saw an issue if I left this as the default settings where basically the firewall would not boot at all. I'll show you here in a little bit how we start our virtual machines, and we would see these icons, which in this case are stopped. It would never transition to the play icon until I made these changes right here. So you may face that same issue. Last, we need to change the console type to VNC, and then we can click Save. The last node here is going to be our virtual PCs. These images are available by default. We didn't have to upload this. So we're going to add 2 VPCs and click Save. Okay, and now we're going to add our management network. So again, we will come to add an object, network. We can call this firewall management. The type is going to be management cloud 0. We click Save. Now we need to connect these nodes together. So you'll see these orange plugs. You can click this and drag it to the nodes we want to connect it to. So my management network, I'm going to connect to Ethernet 2 on each of the firewalls. And that connection will always stay. We're also going to configure Ethernet 0 attached to the management just for now. This is just for the initial configuration. Click Save, and we can go ahead and boot the 2 pfSense firewalls. We will see these icons transition from the square stop symbol to the triangular play symbol. And this tells us these are now running. The color will also change from this dark gray to this darker blue color. Again, tells us that this is running. You can double click on these icons and this will ask you to open the Eve client for VNC access. So we can click Open Eve client, which we installed at the beginning of this video. This will then open Real VNC. And if you're using a Mac and this is your first time using it, you will see this error which says no route to the host is known. So the easiest way I found to solve for this, I'm sure there's a better method, was by taking note of this IP and port number. So we know the IP of our EVE-NG host, and then the port number appears to be 32772. So I'll write that down, I'll click OK. I will then open up Real VNC by searching for the application, and I'll enter in that IP and port number. Press enter. And you will get this request to allow VNC Viewer to find devices on local networks. Make sure you click allow. And then come back in here, double click this node to open Real VNC once again. At this point, you will now see a different error message that says the connection to this device will not be encrypted. You can say, don't warn me about this again, click continue, and we have access to the console of our pfSense firewall. We'll go through the setup on each of these nodes. This is similar to my previous video where we installed this directly to Proxmox. The WAN interface that we are going to use is VTnet 0. Interface mode is DHCP. We will continue. We're not going to assign a LAN interface at this point, and we can go ahead and start this same process on the other node. This will take some time. We'll let it continue before moving on to the next step in configuring the firewall. Once complete, we will click OK, and then we will shut the nodes down. So we'll go to Shell, issue the command power off. This step is optional, but what we're going to do here is we're going to go into our installed image, and we're going to commit the setup changes we made to be used as default for further use in EVE-NG. So that way we don't have to go through the installation and setup of pfSense every time we want to stand up a new pfSense node. So we will go to /opt unetlab temp, and then I'll tab over, and this should autocomplete. Tab once more. I'll look to see what's available here. So we have our two images, 4 and 5. Right now, both of these are configured the same, so we'll go into 4, and we see our disk with the config changes applied. We're going to commit this to the default image that is in our QEMU directory, QEMU/pfSense-2.8.0. So we will do that by running /opt QEMU bin QEMU-image commit, and then the disk name. Once we get this confirmation, we then need to remove the ISO or the installer file so that our images do not get stuck in a boot loop. So we'll go into opt, unetlab, add-ons, QEMU, pfSense, and we want to remove this image. So you can either delete this entirely, or if you want, you can simply move it out of the pfSense directory so that it could be reused at a later date. That way you don't have to re-upload the file. That's what I'm going to do here. So I'm going to move CD-ROM ISO into my root directory, and I'm going to name it pfSense 280.iso, just so I know what it is. Now I should see just my disk file available here. And then in my root directory, I see that I have my pfSense image just simply moved here. If you want to delete it entirely from the system, you can issue the command when you're in that directory, the pfSense 2.8.0, you could issue the command rm and then the file name, press enter, and that would delete it from the system. Coming back into my lab, I can start these nodes once again. And we will start with our branch side firewall. We want to configure this one first. Once the branch firewall has fully booted up, we will see that the WAN IP has been set to whatever was handed out by our DHCP server, so in my case, .32, and I can navigate to that in my browser. The default username here is admin, and the password is pfSense. First time we log in, we will be asked to set up a new password, so we can click next and go through this whole process. We'll call this branch firewall. We will set our DNS servers, and then set our new password. Once the reload is complete, we will click finish. And then we need to allow inbound connectivity on the management interface that we set up. So our management interface is ETH2. So we'll come to assignments and we will add our additional ports here. So click add 2 times. We will use this option 1 or optional port 1 as our management interface. So we'll save these changes. We then can click on our interface to come into the interface configuration. We want to first enable this interface. We can call this firewall management. It's going to be, in my case, DHCP. You can set this up as static if you want. And I will click save. I will then apply changes. I then will come into firewall and create new firewall policies. So I will look at my firewall management port, click add. The interface will be firewall management, address family IPv4. We want to allow any inbound connectivity. Our source, in my case, is going to be the firewall management subnets, which is my home Wi-Fi network. My destination will be this firewall, and I will click save. Again, apply this change. And when I come back to my console that I have open, I can press enter, and I now see firewall management also has an IP address of .34. So now I want to try to access the same management UI, but on 172.16.16.34. Once I've validated that I can log in, I can go ahead and start reconfiguring the WAN and LAN interfaces. So I'll come back to interface, I'll go to WAN. I want to change the configuration type from DHCP to static. And then I will take a look at my diagram here. I see that the WAN interface for my branch firewall should be 1.1.1.2/30. So I can set my IP address as 1.1.1.2 with a mask of /30. My gateway will be 1.1.1.1, and that is into service provider router 1. Save that change. I then will come to my LAN interface. I want to enable it. For some reason, when I'm attempting to configure the LAN interface, I'm running into errors saying the DHCP servers are active on this interface, even though when I come into my DHCP configuration, there are no LAN side servers enabled. So what I'm going to do here is instead configure this from the pfSense console. From here, I'll select option 2, set interface IP addresses. We'll select the LAN interface, option 2. We do not want to configure via DHCP. Our address is going to be 192.168.100.1. This is a /24. We don't need to add a gateway. We do not need to add DHCP v6 or any v6 configuration. Yes, we want to enable the DHCP server. We're going to start at 192.168.100.2, and we can have the pool end at 100.20. No, and this should reload. Press enter to continue, and now we see all three listed here. We can come back into the management UI. We see that this is now enabled, has the correct IP address. We will also check the rules. We have the default allow LAN to any rule has been created, so this will allow outbound traffic for our VPC. We will now make the same changes to the application side firewall, just using the IP addresses that we see for the application side. So in this case, our management is .33. Again, start with adding our interfaces, then configuring our management port. Adding the firewall policy for inbound management connectivity. Finding our firewall management IP, so .35, and then validating connectivity. Reconfiguring our WAN interface to be static using this value 3.3.3.2/30. Adding our gateway as 3331. Validating our change here, and then configuring our LAN interface from the CLI. Option 2, LAN interface, no. Our diagram shows this should be 200.1, so 192.168.200.1/24. No gateway, no v6 needed. Enable the DHCP server. Our pool will be 200.2 to 200.20. No. And then we will press enter and see that all three interfaces are now configured. Again, we'll make sure that our firewall rules are in place. So LAN default allow to any. We can also check that NAT is enabled. It is. So anything sourced from .200.0, our LAN interface, egressing the WAN will then be NATed to the WAN interface IP, which is what we want. We will come back in here and we will stop these nodes, and this will allow us to reconfigure the connections. So we'll delete our Ethernet 0 connection on each firewall. and we will now connect that into SP router. So we will go pfSense Ethernet 0 into SP router Ethernet 01. We will save. Over here, we will go pfSense Ethernet 0 into SP router 2 Ethernet 01. Click save. For our branch, we want to connect into the switch. So Ethernet 1, which is our LAN interface on pfSense, into the uplink port E00 is what we're going to use here on the switch 1. And then connect our VPC into the switch as well. Select which interface on the switch you want to use. I'm going to use Ethernet 03 into ETH0 on the PC. And then on the application side, again, our LAN interface on pfSense is Ethernet 1 into ETH0 on VPC app side. And then the last connection here is SP router to SP router. We will go from Ethernet 0 to Ethernet 0, click save. And then you will highlight all of these nodes, right click, start selected. And this will boot all of our virtual machines. At this point, our Eve lab should resemble what we've seen in the drawing. So we have host connecting into a switch, connecting into a firewall, which then connects to SP router 1, forwarding to SP router 2, then to our application side firewall, and finally our application server. So same thing we see here, host to switch to firewall, router 1, router 2, firewall, application server. We can double click on the Cisco nodes. So I'll start with the switch here. This will open an iTerm window. I can press enter and I will see basically the switch CLI. So if you're familiar with Cisco, we'll start with the enable command. From here, I will do a show run, and we have basic Cisco iOS configuration, no VLANs. Our interfaces are all enabled. We could enter configuration mode by going conf T, but in my case, I'm going to leave this as default config. There's nothing really for us to do here at the switch. We just want to make sure it's up, that our interfaces are up, and able to forward traffic. We will need to configure our routers. So I'll come back here and open my 2 router terminals. So I'll start here with SP router 1. I don't want to enter the device config. We will leave this as default. I suggest you do the same simply because I plan to create some scripts and tools that may help you with automating the breaking of your lab so that you can go through and troubleshoot. If we go through the initial config dialog, it's going to want us to set up passwords, and so I'm simply just not going to do that at this time. We're going to be focusing on router 1 at this point in time, and we're going to keep this configuration fairly simple. So we're going to enter enable, show interfaces, description. Currently we don't have anything here. We'll enter configuration mode, so conf T. First we'll set the host name as SP router 1. We then want to configure interface Ethernet 00, which is our link here connecting to the other SP router. So we'll do interface ET0/0. We could set the description as 2 SP router 2. We're going to configure our IP address as 2.2.2.1, and our mask is 255.255.255.252, which is a /30. We will then exit. Now we want to configure interface ET01, which is facing our firewall. So we'll set the description as 2 branch firewall, and our IP address here is 1.1.1.1. Again, mask is /30. Next, we will add our default route. So IP route 0s, 0s, and next hop is 2.2.2.2, which is SP router 2. So we'll press enter here. We will exit config mode, and then we will do write mem. So now if we run a show run, we should see interface Ethernet 00 connects to SP router 2. This is the IP address. This is to our firewall. So we can do show IP interfaces brief. Again, we see this here. We now see that the protocol is down. So one more thing we need to do here is we'll go back into config mode. We'll go into each interface. We'll issue the command no shut. This will admin up the interfaces. And now we can, again, write this to memory. And if we run show IP interfaces brief again, we see that the protocol has changed to up. All right, for SP router 2, we will do the same thing. So no, we don't want to enter the dialog. We'll go to enable. First, we have to enter configuration mode. Then we will set the host name to SP router 2. We'll then configure the interfaces. So interface ET00, description as 2 SP router 1 IP address as 2.2.2.2 and mask is a /30 or .252. We'll go ahead and no shut this while we're here. Next, we will configure ET01. IP address is 3331. And again, we'll no shut. Go exit. Add a default route here pointed back to SP router 1. And then write mem. Let's make sure we can ping between the two. Okay, so we have connectivity between our two SP routers. Now we will open up the VPCs. We just want to make sure that these have received IP addresses from the DHCP server. So by default, they won't have anything. We can do the question mark here, show IP. And we see that they don't have an IP address yet. That's because we have to manually trigger DHCP on these hosts. So we'll do DHCP, enter. These guys should receive an IP address from the DHCP server of their firewall. So this is my branch client. I see I get 100.2, and on the application side, I see I get 200.2. Now I want to validate connectivity, so I'll try to ping my gateway. Next, I will ping SP router 1. So here we see that NAT is working correctly. Otherwise, SP router 1 wouldn't have a return route for the 192 address space. But because our firewall is natting us as being sourced as 1.1.1.2, which is a directly connected network, he doesn't need a static route and he can basically forward the return traffic. So we know that NAT is working. We want to make sure that this default route and return path is working. So we can go ahead and try to ping through SP router 2 to this interface, 3331. And we see that routing is working correctly there as well. When we attempt to ping our remote firewall 3.3.3.2, we see that the request is timing out. This is due to the fact that our firewall is blocking inbound ICMP traffic. We could add a firewall rule. Once we do that, we would see ICMP responses from the firewall as well. We'll do simple checks from the application side, again, to make sure that we have outbound connectivity. And at this point, we've completed the baseline lab setup that we're going to be using to go through network troubleshooting fundamentals and how things may break in the real world. I hope you found this helpful. In my next video, we're going to talk about the fundamentals of network troubleshooting. We're going to walk through end-to-end how packets flow from the client virtual PC to the application side virtual PC. And we'll talk through the OSI model and the decision-making process of each device within that path and how the two relate to each other. This will lay the foundation for your network troubleshooting for years to come. While the vendor technologies may differ, the process remains the same, and we'll try to make this as simple as possible. Until next time.